Ignacio, are you on? Yes, can see.
Okay, can you hear
See
me?
that's good. Perfect.
Okay. Good morning to everybody. Thank you, Daniel, and thank you, Tommy, and thank you to all the staff of Fox Center for inviting me to this interesting workshop. So I'm going to present here an overview about the work that was done in the frame of the Task 41, the International Energy Agency. And the main objective of this work was just to find solutions, so potential solutions to reduce the cost of levelized cost of energy on distributed wind. And one of the idea was just to find potential downscaling ideas from medium or large wind turbines to small wind turbines in order to refine the design of the small wind turbines. So this was the main aim. We had identified several potential ideas, and the second phase of the activity was just to analyze the cost benefits of the different ideas identified. And this is still ongoing this work. So this is a progress view of this activity. Let me see if I can. Oh. Okay, this is the. So this is the scope of the work. I want to mention that this work has been done by several partners of Task 41. So mainly for Ian Baring-Gould and Trudy Forsyth from NREL and from Wind Advisors. And some other partners from this task were working on this activity also. So the first question is just to define the design changes that using large wind turbines that could be downscaled for distributed wind turbines in order to reduce the distributed wind LCOE, levelized cost of energy. Some of the ideas that we are going to see here has been already mentioned. It's really interesting that it has been mentioned in other presentations today, and previous presentations. But this is really interesting just for us to see that these ideas can go forward in this aim to reduce the cost of the energy produced by the small wind and to be more competitive in the future. So another question is how to resolve technical issues with smaller wind turbines below 30 kilowatts and less. Maybe where downscale is not necessary. So those are the research topics, the ideas. So some of them are very well known as just to design wind turbines with taller towers, wind turbines with lower specific power. So it's important that if we analyze the potential of reduction of cost of wind turbines, so there are several areas of development, like for instance, learning by deployment. So it's strongly dependent on the market, how many wind turbines are going to be in the market. So learning by research, this is more or less the activity we are addressing here. It's very important just the supply chain dynamics, how the supply chain is operating. So for instance, it has been mentioned the collaboration with other companies from the automobile sector like Toyota. So this is really interesting in order to produce potential reductions. And obviously market dynamics. So this is probably the more difficult even in this situation of high cost of energy. So this is one of the most important, the key points in this activity. So lower specific power turbines is very interesting. So in large wind turbine, this is done in order to extend the application of the wind turbines to areas with lower wind resources. And this is very related to the deployment, the high deployment of the big market needed or expected. So behind the metal grid services, so this is interesting. So the big market is working on that just to get benefits from the support of the grid system. Why not the small systems? Don't mind if it is just a standalone wind turbine or a hybrid wind solar system can support also all the requirements of the grid codes. Grid codes are getting more strict in nowadays, so all requirements should be a very interesting opportunity to get benefits. Life cycle cost of isolated power systems has been already mentioned. So these isolated power solutions are really this is the real niche market of small wind. Value of the integrated storage. This is very related to the cost of the storage solutions and the regulation. So it's very related to this, but it's clear that it's going to be all these systems are going to be face to face with a storage solution, but the cost of the storage solution is one of the main inputs. And value of optimization and distributed generation within the region is important in order to get a sufficient critical mass just to develop the distributed wind. Just in order to be, obviously, we are not talking about wind farms, but we are talking about several installations that are nearby, not very far each other. So in order to establish a critical mass mainly for operation, maintenance of these solutions, to reduce this cost in the operation in the future. Reduced weight wind turbines. This is very related to the materials, to the new materials, to the new design solutions. We can learn something from large wind turbines that are modular solutions. This is another important issue. Direct variable frequency applications. So production of ice, water pumping, irrigation, water desalination, direct heat, even hydrogen. Direct hydrogen production. Nowadays, maybe very costly or but this kind of solutions, distributed wind can support and offer interesting solutions. Some of them more costly or some others more general. Some of them has been already mentioned as in this conference as a water pumping or irrigation, but others like hydrogen are still ongoing or just looking for the competitiveness. So optimization of installation methods and foundation design. This is an important thing. So foundation is competitive solutions for installation, avoiding cranes, costly cranes or foundation designs, standards for different soil conditions for different that can make easy or reduce the cost of the installation of the wind turbine are really strongly recommended. Some activities related to this have been already done for small wind turbines manufacturers all over the world. But I think that maybe standardization in order to reduce the cost, standardization and systematic approaches to reduce maintenance for the distributed wind fleet. So this is very related to the distributed generation within a region. And there is a horizontal area which is showing large wind. Now there is a great interest on industrialization. So cost reduction by the industrialization of the different components. So no using 3D printing solutions. So standardization and industrialization. So I think that this is a pending question in the small wind, so related to the supply chain industrialization. So in order to reduce, it's clear that it is a big market is required just to deploy these strategies. But it's this is a question that is needed just to be solved or to be developed in the future. So, but all these research topics, all of them need cost model for LCOE comparison in order to see what strategies are good or maybe not for the future. So if we look at the research topics, taller towers, so for largest wind turbines, the economies of scale allow for the consideration of taller towers. But for smaller distributed wind technologies, the cost of the towers is typically half of the turbine system cost. So the sensitivity is really important. There are some questions about this topic, like what are the trade-off between towers and large and distributed wind turbines? What are the logistic impacts or drivers such as crane heights, shipping, or transportation of tower? Can different materials for towers and foundations impact some of these decisions? Is there an optimal height for different sites based on wind shear patterns and site characteristics? How can handle permitting and social acceptance issues with increased tower height? It's really important issue in distributed wind. Is there a need? It's very close to inhabited areas. Is there a need to analyze the uses of different tower types and heights for specific wind turbines? So those are questions that can be resolved in the development of the work. So, for instance, if we look at the taller towers for large wind turbines, we see here what is the expected reduction in the levelized cost of energy versus half height wind turbines, and we see that we can get even around 7% of reduction of the LCOE. But we need to take into account the cost of the solution, the type of tower that we are going to use. So anyway, this analysis is very related to the very precise wind resource assessment in order to know what is the wind shear, what is in the site where we are going to install our wind turbine, and cost competitive tower is interesting also. Which solution is the best? So we have seen tubular towers, or we have seen different solutions. So especially for downwind wind turbines. So which is the best solution? Even if we need to install a tall tower to get a better LCOE in our system. Lower specific power wind turbines. So it's clear that larger rotors capture more energy, and there in the big wind sector, so it has been developed so many lower specific power wind turbines, and especially for sites with a moderate wind, which is the most standard situation all over the world. So this is really interesting. The important thing is what is the increase of the cost, the capex of the wind turbine, because of the larger wind turbine or even the larger control system. So this is really important. So we need to analyze the situation, and we need to develop different solutions in just according to the standard, the IC standard. So in the end, there are several classes of wind turbines. So in large wind turbines, this is very common, but in and small, medium-sized wind turbine. Medium size is getting better, but it's really strange, or very rarely we can see different wind turbines with the same power and different swept area of the rotor. But this is interesting just to adapt to the wind turbine to the site conditions. But obviously we need to know perfectly the wind resources system before to choose the best wind turbine for this place. This is, in my opinion, one of the main problems or issues about barrier. Because small wind turbines are installed in unknown locations, so obviously developers or OEMs are tend to develop, to design heavy machines with high factor safety. So there is this in one way is just about opportunity to reduce the cost if we develop a better solutions. For instance, just to embedding solutions just to analyze the health of life of the wind turbine, better solutions just to assess the site resource, better solutions. So something like twin solutions just to know the situation of the wind turbine. So we can adapt some of the methods that are already used in the large wind sector to a small wind sector. We have also some questions like, what are the standard rotor, generator, and power converter cost, loads, and reliability trade-offs to lower specific power wind turbines? Are there appropriate methods of assessing the wind resource at distributed wind customer locations that can encourage the use of low specific power wind turbines? This is an interesting question. In general, is there an optimum specific power wind turbine for the distributed wind market? What are the component changes needed to lower specific power? How will changes to the component impact the full wind turbine design? What are the likely near-term component innovations? For instance, we are talking about extended blades, for instance, or modular power electronics in order to adapt the easily cost-effective solution, the wind turbine for the site wind resource available. So there are some comments about the possibilities of, here we can see some comments about the possibilities of lower specific power wind turbines. For instance, it's clear that lower specific power wind turbines reduce the LCOE, but for instance, innovation in blade design and materials is required. So in order to minimize the scaling related cost increases associated with larger rotors. So this is an important thing. So research is needed just to reduce the cost of this larger blade. Another comment is the overall analysis suggests that under reasonable scenarios, low specific wind turbines can play a significant role in the future. LCP turbines will provide a higher capacity of utilization factor, even in low wind sites, and may reduce the levelized cost of energy to an extent of 60%. So this is just an analysis for large wind turbines. So the idea is just to develop this, to analyze the different components for small wind turbines. This is more difficult because of the lack of information, available information, but this is the idea just to develop in the future in this work. So the main achievements or main requirements are always the same: the precise wind resource assessment and cost competitive blade design and material as a first component in this strategy, but also something about the power electronics is required, or the system of torque control obviously is needed. Modularity could be the solution. Another third research topic is behind the meter grid services. So this is a very interesting, because we can value these energy services with even with small wind turbines, especially for grid ties applications. There are some questions, obviously, what is the economic and technical value behind the meter grid services for industrial plants in different countries with different power costs? It's strongly dependent on the regulation. What is the economic and technical value of distributed wind in front of the meter? Are there optimal locations for distributed wind at present? Are social acceptance issues that need to be addressed? What are the different costing models for compliance with different country laws? So resource assessment is always needed, site resource assessment, but also in this case, the regulation, the country regulation code of different countries is extremely, this strategy is extremely sensitive to this, to the regulation, the local regulation of the Greek code. Life cycle cost of isolated power systems. So
About 5 minutes left.
thank you, Daniel. So this is another important. So our markets are more likely to use PV than distributed wind. It has been already mentioned because of the cost of different cost of resistance. But there are also an interest to analyze, to develop models and tools just to develop these strategies of isolated solutions, hybrid solutions, which are really interesting. In terms of LCOE, total LCOE of the whole system. Value of the integrated storage. So storage is interesting, and also to offer the energy produced by the distributed wind system in the best period of time, in the high cost period of time, but cost of the solution and the integration. So solution required just to integrate in a optimal way the electronic solution. So is needed to be addressed, and general cost of energy storage, adequate sizing of energy storage device is really important just to integrate in the right way in the system. Value of optimization of the distributed generation within a region. This is very important in order to get a critical mass. It has been already mentioned, especially related to the operation and maintenance of this kind of solution. So in order to reduce the cost of these activities. Reduce the weight wind turbines. So this is clear. Some wind turbines are really too heavy, just in order to develop a very robust solutions for every site. So the idea is just to define different solutions for different conditions of wind resource. So this is really interesting, but it's required a very good wind assessment solution. And it's very related also to logistics, all related to installation, cranes, and so on. Is all related to weight is very important, and also materials. What materials, new materials, are offering solutions, low weight solutions for wind turbines. Variable frequency applications. It has been already mentioned. Wind turbines just for specific productions. Like ice making, water pumping, irrigation, direct heat, even hydrogen is a good solution. The system in the end it can be simplified. So this can affect to the cost of the energy produced and the final cost of the system. So, but also precise wind resource assessment is important, and competitive power electronics, because it's very dependent on the technology, power electronics, power conditioning. So finally, we address the installation methods and foundation design. Yes, in order standardization is really important in these topics for different in order to have several solutions for different types of soils or different in order to reduce the cost of this installation and the foundation. So some developments has been already done. But I think that the standardization is still pending. and strategies to reduce the maintenance of distributed wind fleet. So this is very related to regional to the way to develop the distributed wind in order to generate enough critical mass. Development of multiple installations in nearby sites is really interesting in order to establish a cluster, something like a wind farm, but in different areas, in different sites. Should be interesting in order to reduce the cost of the system. And that's it from my side. So if you have any question, I will be happy to answer. Thank you.
Thank you, Ignacio. Is there any short question? Yeah, no, if there is any question, I cannot see the screen.
Okay.
Otherwise, yeah, thank you a lot